Greetings, this is the man who pretends to be Charles Darwin, and I'm here to talk to you about an old science book. You probably can't find this around anywhere. It was written in 1912, at least the American version was published in 1912, and it's called In the Guiana Forest. And it's by James Rodway, who worked at a museum in British Guiana. And why would I read this book? Actually, that's what I'm here to talk to you about, the things that I learned from reading this book. It's actually a beautiful book. The pages had to be cut by the first owner of this book, who was Arthur Vestal, an ecologist at the University of Illinois. Well, there's several things that we can learn from this book. And the first is, of course, as you would expect from 1912, there was something of a racist undertone to it, which a lot of white people shared at that time. And for instance, he referred to the Native American peoples of Guiana as savages, and he said that they did not operate by reason, but rather by instinct. Now we know that this is offensive today. And he said this even though he made it very clear that he liked them and that they were perfectly adapted to their environment, which we white people cannot say about ourselves. Also, there's lots of stories in here, many of which we assumed were only discovered in the 20th century, but actually they date back to the 19th century. For instance, the story about ants, entire colonies of ants that live in the root volumes of orchids up in the branches of the trees, and that they defend the orchids from herbivores. And he also knew about the leafcutter ants that would grow gardens of fungus in their colonies underground. And so we knew a lot of things back then. There are other things, however, that we have to ask ourselves, how long have we known this? What's it going to take for us to understand this? For instance, he wrote about mangroves and how mangroves are these thick shrubs that grow along the shore in tropical areas, and that their branches and their thick roots hold down the soil, and they slow down storm surges, so that when a storm surge comes over them, it'll slow it down. Even if the storm surge is higher than the mangrove, still the friction will slow the storm surge down. And as evidence, he pointed out that in those places, even in 1912, where the mangroves had been cut down, those places are where the storm damage was the greatest to property and to agriculture. Now, we've known this for a long time, haven't we? And yet, even to this day, people cut down mangroves, even though there is an economic and agricultural cost to be paid for that. That mangroves provide an ecological service. He knew that 100 years ago, more than 100 years ago. Why don't we know that today? Another thing that is perhaps the most interesting about this book is to see the process of scientific discovery, breakthrough, and understanding. Now, when he talks about the process of evolution and genetics, he is very unclear in here. But it's sort of a mixture of blending inheritance and a little bit of Lamarckism, as we call it today, which is the feedback of the environment into genetics. We know that that doesn't happen today, but he was doing the best he could at the time to understand the process of genetics. And at that time, the work of Gregor Mendel, the Austrian monk who discovered about how genetics works with dominant recessive alleles, etc., that work had been done in the middle of the 19th century, but it was rediscovered in the early 20th century by De Vries and others. That had already been done 10 years before this book was written, and yet he didn't know it yet. Okay, it takes a while for new discoveries to diffuse out into the common understanding of science, but there's something else here, and that is that perhaps even if he had known about the rediscovery of the work of Gregor Mendel, that doesn't mean that he would have believed it, because it takes a certain amount of time for these discoveries to be accepted once they have been revealed. Sometimes the textbook version of the scientific process is that scientists make this great discovery and instantly the light comes on in their eyes and they know what the truth is. Alexander Pope wrote about Newton. He said, "And God said, 'Let Newton be,' and all was light." Well, that's not the way science works, and this book is an example of that, because yes, he had revealed, or De Vries and others had revealed what Mendel had discovered, but that doesn't mean that everybody instantly accepted it, because, for instance, the ratios and the data that support Gregor Mendel's interpretation weren't always very clear. Okay? The same thing happened with Watson and Crick's discovery of the structure of DNA in 1953. We assume that when they published their paper, instantly everybody knew that it was correct, but that is not true. It took a while for people to be convinced. Rosalind Franklin, for instance, read the paper and she thought, yes, this is beautiful, but is it true? It took a while for the discovery to be appreciated. There's an initial resistance against new discoveries, and that's the way it should be because extraordinary claims require extraordinary evidence. And so that's what we see here, that even after the rediscovery of Mendel, people were still struggling with old-fashioned views, and that's because it took a while for scientific views to be accepted generally in the scientific community and in the public. So that's what I learned from this. I learned a little bit of humility as a scientist, that it's not like we make a discovery and instantly everybody knows that we're right. And that's what I learned from reading this book. You probably can't find this book, but anyway, that's what I learned from it. This is Charles Darwin, or the man who pretends to be Charles Darwin, telling hope, and amen.